Well, I'm going to kick it off, and I'm going to start by sharing my screen and walking you through a few things. All right. So welcome to today's workshop session on the future of data. We're talking about law, technology, and policy. I'm going to go through some introductions. In the next few weeks, we are going to be launching our new initiative that focuses on the future of data, trust, and privacy. This initiative is going to be led by Danny Weitzner. He is the founding director of MIT's Internet Policy Research Initiative and the 3Com Founders Principal Research Scientist at MIT Computer Science and Artificial Intelligence Laboratory, CSAIL, as well as Srini Devadas, who is an Edwin Sylvia Webster Professor of Electrical Engineering and Computer Science at MIT, and also a researcher in MIT's Computer Science and Artificial Intelligence Lab. I am Lori Glover. I'm the Managing Director of Global Strategic Alliances for CSAIL, and I'm going to talk for the next few minutes and kind of just give you a lay of the land of what we're doing here, things we'll be talking about, and why we're doing this now. So, welcome. First of all, just a couple of minutes on the MIT landscape. So MIT has world-class researchers who are working on really today's most pressing problems. And I think everyone can agree that privacy, use of data, data security, these are all really, really important problems. MIT is organized into labs, we mentioned CSAIL, academic departments, as well as centers. And at MIT, the faculty have teaching appointments in departments, but research appointments in labs and work together in centers as well. This collaboration across these disciplines, this is what's really important and really impactful. It can be really game-changing. And that's one of the things that we're also trying to focus on here. So we've heard the CSAIL and IPRI. CSAIL is MIT's Computer Science and Artificial Intelligence Lab. It is the largest lab at MIT. It represents 11 different departments across the institute, and it does have a structure in place to engage with industry. IPRI is MIT's Internet Policy Research Initiative. It is interdisciplinary, involves policymakers and technologists in conversations, and really focuses on technically informed policy. It is CSAIL and IPRI that have come together to work on the future of data, trust, and privacy. So just quickly review the agenda. I'm going to do your introductions and talk a little bit about why data privacy is so important right now, and not only data privacy, but just the use of data in general, everything around it. Then we're going to hear from the co-directors, Danny Weitzner and Srini Devadas. And we're going to take a break. We're asking you to go and grab some lunch and come back and join us. I know many of you submitted questions with your registration, which is fantastic. We already have a fabulous group of questions for the discussion part. But I'm also going to encourage you that if you have questions during the presentations from the researchers, to please use the chat feature and submit your questions, and we'll be able to use those as well. And then we're going to just do a wrap up and conclusion at the end of the Q&A. So with that, I'll talk a little bit about the current landscape and challenges facing business today and why this is so important. So we've all seen the headlines, right? The last several months, WhatsApp delays privacy changes amid user backlash. We've got email security firm Mimecast as hackers hijacked its products to spy on customers. And German regulators outlawed just about all of Facebook's whole ad business. California voters improve expansion of data privacy. Google's fined £44 million for privacy law violations. And GoodRx saves great money, but it also shares your data. And then we've got New Zealand Central Bank. They have another data system breach. These are all recent headlines. We all know that data is impacted in all of this. So this is from Forbes back in 2017, that the world's most valuable resource is no longer oil, but data. Data is critical to everything. Artificial intelligence, machine learning, search, marketing, IoT, autonomous vehicles. Data is the core of all of it. And every company needs to understand how to manage this data, can comply with privacy, not only laws, but also expectations, deal with the cybersecurity risk, and technical realities. Companies in every industry sector need to be able to deliver these solutions to use their data, and analyze massive amounts of data. And this quote from McKinsey is always interesting as to why it's important for companies, is that consumer loyalty is on the decline. Competitors are even closer. They're just one click away from your customers. So let's talk a little bit about the foundations of privacy law and policy. We all know Europe and California have introduced regulations to protect privacy. Compliance with GDPR or CCPA, CPRA has challenges. There's a lot of reliance on temporary controls and manual processes until a more permanent technical solution can be in place. That's really time consuming and a drain on resources. It's not something that's sustainable. And again, pointing to a McKinsey report, there are 3 areas in particular that need control: security, data management, and automation. Expect more of this. Maine, Maryland, Nevada, New York, a whole bunch of others have passed their own privacy laws. Data privacy legislation is a focus for many more state governments, which means we're going to have a lot of different laws to try and figure out how to work through and with. NIST developed a program for framework on privacy, and even on the federal level, the Congress has released drafts of broad conversations on federal policy legislation. So this is something that's continually growing, that is just going to become more and more prevalent in the business landscape. I had to throw this in here on trust. This is from Pew Research Center, and you talk about people whose data is involved with these companies, and the majority of Americans feel they have very little control over any data that's collected about them. But not only a lack of control, they don't even understand what's being done with the data and how it's going to be used. So there's a trust problem that's also fundamental. Again, why we have trust in the title of our initiative. It's an important thing to deal with. And of course, once you have all of that data, it's keeping it safe. On my right-hand side is the chart that talks about large-scale data breaches that have affected millions of people. Seems like we're hearing about a data breach every other day. And it does really do damage to brand and trust and ability to continue to work. Over here I have the quote that it takes 20 years to build a reputation and only a few minutes of a cyber incident to ruin it. Down here, I'm not going to show it, but I just had to put it out there because it is an incredible visualization of cyber issues and breaches and challenges with data back to 2004, and it just shows an absolute explosion across all industries, companies large and small, just in the last couple of years. Again, like with the privacy laws, keeping data safe and the challenges with that's not going away either. It's just getting more and more complicated. So data governance. There is a need for automated and streamlined technologies that do comply with the regulations, more secure data management, tools to better assess risk, privacy preserving technologies, building that trust, and securely sharing data. I think some of you have heard about SCRAM, which is also related to this, and I'm sure that Danny will be talking more about that. But that is another really interesting application of the technology and being able to share data privately and be able to get some really great insights from it. The bottom line, data is essential to business success. So understanding how it's going to be handled on the policy side and the technical systems in place to deal with the proper handling is critical to success. So in this landscape of increased regulation, challenges with consumer trust, the critical importance of data security, and need for improved technical tools, we are looking at pulling together a new initiative on the future of data, trust, and privacy, with the ultimate goal being bringing the state-of-the-art MIT computer science research together with world-leading public policy expertise and engagement. Why now? Because initiatives are formed when there's no commercial solutions to challenges being faced, and our research is actually addressing these challenges. Future of data is being formed, so we welcome input and discussion. The future of data will have both technical research that addresses these challenges, as well as convene discussions with policymakers and others. The goal is really looking at technically informed policy as we work through these challenges moving forward. And with that, I would like to turn this over to the co-directors of the MIT Future of Data, Trust, and Privacy Initiative. They will be speaking Danny Weitzner and Srini Devadas, and Danny Weitzner will take center stage now. With that, I'm going to stop sharing my screen and turn it over to Danny.
Thank you so much, Lori, and welcome everyone. It's great to be with all of you. As I talk, I will get my slides fired up here. Thanks for agreeing to spend a couple hours with you. Srini and I are gonna, as Lori said, give a quick chat about uh, the motivations for this initiative, how we're approaching these questions, both the public policy questions and the computer science research questions. But really, we want to hear from you. So Laurie, I think, outlined really well a lot of the challenges that we face in this area. And it's really no exaggeration to say that technology, information technology, really is at the center of a lot of the trust gaps that we face in society today. These exist at a global level, at national levels, at the enterprise level, between employers and employees, between businesses and their customers, really at all levels. And our aim really is to make sure that we have the technical infrastructure necessary to address these issues, and that the design of that infrastructure is informed by public policy needs. And at the same time, that policymakers who are addressing all these questions of privacy and cybersecurity, fairness and reliability and machine learning have the tools, the technical understanding necessary to make wise policy. Just to put a point on this, some of the central trust questions we have in our societies today are about voting. Do we trust the results of voting systems? They're about cybersecurity. Do we trust other companies to handle our personal data? Do companies trust each other? And so these are some of the questions that we aim to address in this initiative. I want to just start by giving a bit of background, a bit of my perspective on how the public policy environment that we face here, that we're in, has evolved. And it's really important to recognize that I don't think we're coming at these set of questions blind. We actually have 4 decades of computing leadership, beginning with the personal computer, extending through digital telecommunications, the global internet that was developed extraordinarily rapidly, mobile ecosystems that people rely on, and finally cloud computing. And in a relatively short period of time, we've been able to develop all these multi-layered infrastructures that in fact our societies have come to rely on, and in a certain measure have come to trust. And I want to, before we delve too much into the challenges that we face, I want to point out ways that we've been able to combine an innovative direction, in innovation environment for these new technologies with the right public policy environment to assure that they can grow and assure that people can use them with confidence. So I'm going to give you a little kind of thumbnail history of the last 3 or 4 decades of internet policy. And my view of this is that there are really some foundations, some public policy foundations that have shaped the way the whole internet environment, the whole digital ecosystem has evolved around the world. We tend to think of the internet maybe in a caricatured way as a kind of a lawless environment, as a Wild West. But the reality is there were some very important policy decisions that were made early on that enabled a lot of what we have. And I think it's important to understand those as we think about how to build trust going forward. So the first foundation of internet policy actually is legal protections of free speech and freedom of association. The internet and all of our digital ecosystems are information environments. So we have to assure that information can flow freely in these environments, and there's legal protection, human rights doctrine, US Supreme Court cases that actually guarantee these protections early, and those were put in place early on and were an important part of the way the internet developed. We've made some early decisions in the 1990s about the regulation of internet platforms. We actually set some rules out about what platforms we're responsible for and we're not responsible for. And that also enabled enormous innovation and enormous growth. We have some questions as I'll discuss about platform regulation, but it's important to recognize that foundation. Of course, people know from a technical perspective that the internet has been based from the beginning on global interoperability standards that were developed very much in academic and technical communities, less so in government and regulatory environments, the way some other global infrastructures have developed. We did take early on a relatively light touch approach to privacy and cybersecurity. We relied on quite a bit of self-regulation and co-regulation and targeted enforcement, sector-specific privacy rules. But until recently, until the end of this period in 2018, we haven't really had comprehensive privacy protection, and we've had really very modest and arguably underpowered cybersecurity regulation, but that's been an important part of the growth as well. And then, of course, from the very beginning of the internet, there was a struggle over the availability of cryptography. Cryptography used to be regulated as a munition, and there was a big struggle through the 90s to free up that technology so that it could be used for all the e-commerce and commercial applications that are so critical. So we have these foundations that are based on very, light touch regulations, not no regulations, based on global norms. But it's also the case that some of the key externalities, the costs associated with building a global infrastructure, especially in terms of privacy and cybersecurity, were not exactly addressed completely in these foundations. But we should recognize the enormous success of this first few decades of the digital environment. I like to think of it as a $6 trillion, 3 billion person enabling policy framework. This set of policies came together and enabled just these 4 companies represented here, which are on order of $6 trillion in market capitalization. And of course, I don't include all the numerous other companies and industries that benefit from this environment and produce value in this environment. By the same token, we got 3 billion people around the planet online in an extraordinarily rapid, at an extraordinarily rapid pace. So there's some successes here that we should learn from and build on as needed. But there really are gaps that we have to focus on in this policy framework. I ended the period of time I was discussing at 2018 because that's when the European Union GDPR went into effect, and I think that does mark a very important shift in regulatory posture. It's a shift from what many characterized as permissionless innovation to more permission-based innovation. That is, under the GDPR, strictly speaking, any use of personal data has to be legally authorized in some manner. And that's a very dramatic change, and one that requires a new set of business strategies and also a new set of technologies to support that. But by the same token, I think there are very important new opportunities, both in developing new product categories and in building new kinds of customer relationships based on better data governance strategies, more customer engagement, more careful look at how we deploy new artificial intelligence and machine learning technologies, and new approaches to cybersecurity, which I'll talk about. Questions about the availability of cryptography continue. There's ongoing pressure on many of the platform companies to limit the power of their end-to-end crypto systems in order to facilitate law enforcement surveillance. That's a debate that's going on right now, particularly as Facebook integrates WhatsApp into one single messaging platform. That's an ongoing debate that we're spending a lot of time looking at. There is obviously quite a bit of pressure on the question of how to regulate platforms and what kinds of obligations to put on them, particularly with respect to disinformation and crime. I think there are also, though, new opportunities in developing new content moderation technologies, applying new artificial intelligence techniques, and developing new norms there. And we have pretty critical questions about the global commitment to interoperability standards that have up until now tied together the internet and a lot of the data-driven infrastructures that we depend on. We are seeing a new kind of mercantilism where China is working to develop its own sets of standards And we do risk balkanization of the global internet environment, a loss of Bob Metcalfe's famous network value. Um, and so we've got a lot of work to do there in looking at those policy questions. Starting several years ago, MIT institutionally recognized that leadership in computing is no longer purely a technical question. So in launching our new Schwarzman College of Computing, which is a $1 billion new effort to create a whole new approach to research and education in computing, one of the three goals that our president identified was to make sure that this new College of Computing would be a place for teaching and research on policy and ethics that address the challenges that computing has raised in society. This is a relatively extraordinary thing for us. We have tended to focus institutionally on the technical questions associated with computing, and we think we've made a lot of contributions there, but we now recognize that we have to broaden our focus, and this Future of Data initiative is a key part of that effort. I want to just go through a couple of the research activities that we have that are inspired by this view that new directions in computer science really have to address not just developing greater, more powerful, more efficient technical capabilities, but also really address the needs that society has. And I'll talk about three initiatives. Laurie mentioned the Scram research activity, which we've had going for a few years now. We realized several years ago that though there is an enormous amount of focus on cybersecurity, companies spend an enormous amount of money trying to protect themselves from risks, that we really lack basic empirical information about the nature and magnitude of cyber risk and the source of cyber risk. So we know a lot about attacks that come in, and companies are getting better and better at sharing information about threats, but we really know very little about how to price those risks. The lack of that pricing means that CISOs have a hard time making investment and prioritization decisions simply because they don't know which kinds of security controls require the most urgent investment. This inability to price cyber risk, to really understand where the greatest needs are, limit the quality and economic efficiency of cyber insurance. Firms are relying more and more on cyber insurance, and at the same time, insurance companies are trying to figure out how to provide more comprehensive coverage. But in order to do that, they need a better window into the precise nature of risk, and policymakers and regulators are really struggling with how to set the right kinds of security standards for the companies that they regulate and oversee, simply because they don't have the information about what are the most pressing risks and where the biggest losses may be. So we launched this project, SCRAM, the Secure Cyber Risk Aggregation and Measurement Project, with the goal of building a platform that would enable us to collect information securely from companies that will allow us to look at the nature of their defenses, the kinds of attacks that they suffer, and the economic losses associated with those attacks. If you can bring all that information together and analyze it across enterprises, you can actually begin to develop a sense of what is the price of different kinds of risk. We've done this using an innovative new security technology, cryptographic technology, homomorphic encryption, and secure multi-party computation, which enables us to actually compute on encrypted data. So companies naturally are very wary to share detailed information about the cybersecurity losses they experience, or even about the defense posture of their systems. So we have them encrypt that data in a particular way using these homomorphic encryption approaches. And then we're able to compute aggregate results on that data without anyone not the other companies that participate or us ever seeing the raw data, but everyone is able to see the results of the aggregate computation. So as we learn more about risk, everyone is able to share that knowledge. We're able to do things such as categorize losses by category of defenses that failed. We're also able to learn things, for example, that even though in many cases companies have indicated that they have implemented a particular control, there still seems to be failures with those controls. So we're at the very beginning of this process of learning how to study price-driven risk across a number of enterprises, and it's a very exciting part of this initiative for us, and happy to talk more about that as we go. Laurie mentioned the challenge of GDPR compliance. This is just a very quick view of the different requirements that the GDPR and other privacy laws being enacted actually impose from a systems perspective. What we've learned in analyzing these laws and talking with companies is that many of the legal requirements for complying with the GDPR are actually ones that are very hard to implement in today's database infrastructure. For example, it is a requirement that companies, before they process personal information, get consent for to use that information for particular purposes, and then guarantee that they will never use that data for those purposes. Well, databases today do not have the ability to track those kinds of purpose commitments that are made to control queries based on that kind of purpose limitation. The GDPR also provided a right to erasure, what you might think of as a hard delete. So anyone who is protected by the GDPR has the right to have data that's an organization holds about them deleted. Well, the problem is organizations have a very hard time figuring out where all the instances of any one person's data actually are. So it makes deleting particularly difficult. These are just two examples of a number of privacy challenges that we're working on implementing. We've done some early work in developing a new version of relational database architecture to be able to allow enterprise scale databases to control queries through purpose filters, and also to be able to, through provenance tracking, identify where all the personal data is for any given data subject in the event that they actually request a deletion. Voting has been very much in the news in the United States, at least over the last couple months, obviously, and particularly trust in our voting systems has been an enormous question. In a desire actually to expand access to voting, some companies have begun to develop internet-based and mobile app-based voting systems. These are done for very noble purposes. We want to make sure that people, wherever they are able to exercise the right to vote, including soldiers who may be deployed out of the country. But there's been controversy and criticism for quite some time from the computer security community, expressing general concerns that it's very hard to build a reliable, secure online voting system of any kind, and that deploying such systems would reduce trust. Well, there are companies and voting jurisdictions that had begun to deploy internet-based and mobile app voting systems. We decided it was important to go beyond the kind of general security debate about whether this was a good idea or not, and actually study one particular voting system which was being deployed in a number of jurisdictions around the country. This was a app called Votes, which was being used in West Virginia, in Utah, in Nevada, in Washington State, and elsewhere. And we learned that there really were very substantial security flaws in this system, some of which we think would really be very hard to sorry, I just heard a funny sound. Some of which we think would be very, very difficult to fix with any kind of simple patch. We actually reported these results to the Department of Homeland Security, which has a unit that monitors election security. Engaged with a number of voting jurisdictions around the country. The New York Times noticed this, and the result was that a number of jurisdictions that were beginning to use this app decided not to. And this is just really an example of the kind of research that we think is important to do in the Future of Data initiative. When there are policy debates about what the right security choices are to make, what the right privacy choices are to make, we really want to make sure those choices are informed by concrete technical analysis. I'll just close by saying our work will be informed, first of all, by the public policy research we do, certainly by the computer science work that will happen across the lab and across MIT, but also by really careful engagement with policymakers and through education. Over the last number of years, the last 5 years, IPRI, the Internet Policy Research Initiative, has worked on a variety of public policy issues about surveillance and encryption, issues about digital trade, issues about AI policy. And what's been important to us always has been obviously to ground our thinking in the best computer science understanding and the best computer science research, but also to engage with policymakers, engage with civil society organizations, with industry, and with members of the public. And we've done that in a number of areas and look forward to continuing to do that as we go forward. In many ways, our most important product, if you will, at MIT is the students who we train. So we have a large number of students who take classes that they're taught by IPRI faculty, are doing research in a variety of areas related to privacy, cybersecurity, AI fairness, AI reliability and explanation. And through this initiative, we're excited for our students to have a chance to work with hopefully many of you on some of the challenges that you see. And if all works out, you may even be able to hire some of them at the end of the process. So with that, I will turn it over to Srini and look forward to, or maybe we're going to do some questions now. I don't know, Lori, what's our plan? But I'll thank you and look forward to talking as we go through the morning.
Great. Thank you so much, Danny. Matt, do we have any specific questions, or are we going to just hold it for the Q&A?
I have a question for Danny now.
Sure.
So just a question for you, Danny. What limits should there be to the use of individuals' data, and how privacy and rights can be respected during the data collection?
Well, I think that the key thing that we're learning about privacy is that it's not an all or nothing property. We have, I think, in computer science tended to think of privacy through the lens of cybersecurity and say, well, if we can just lock up data, lock up personal data, protect it from anyone, then you'll have privacy. What we're learning is that things are more complicated than that, and that people are willing to have their data used for certain purposes, want it to be used for certain purposes, want to get certain kinds of value out of their data. Companies want to extend propositions with respect to certain uses of data. And the key thing is to stick to that commitment, the commitment that says, if I use your banking service, sure, I want to get information about how I can, use my money better or get credit offers if I'm interested. But if I discover that the banking service I'm using or the lending service I'm using all of a sudden is feeding into decisions about me, about whether I should get a certain job or be admitted to a particular university or who knows what, or qualify for health insurance, that's going to make me nervous probably. And it's going to make me less likely to want to trust the financial services company that may have something I really want. So the key, I think, is to make sure that we're able to have purpose-based limits on how data is used, and that we have systems that can enforce that, and ultimately systems that can prove to customers and ultimately to regulators that those purpose-based controls are reliable. I'll just say I believe very strongly that you know, people want to go out into the world and interact. People want exciting new services. People want convenience. People want lots of things from their data. Enterprises want lots of things from their data, from their customers' data, and we can do a lot of that as long as we can define the lines based on what's respectful and what's agreed, and to make sure that those boundaries are actually enforced in a trustworthy and provable and accountable way.
Great. Thank you. So with that, we will turn it over to Srini, and we have a lot of opportunity for Q&A at our presentation. But Srini, the floor is.
Yep, can you hear me, Laurie and Danny? Thanks, Danny, for the nice setup. What I'd like to do over the next 20 minutes or so is give you folks a sense for the broad spectrum of techniques that one could potentially use to solve kind of the hard technical problem of data privacy. And I put old in quotes because I didn't want to get confused with to think that old meant obsolete. There's techniques that have been around for a while, but there's still challenges associated with these techniques.
MIT Alumni Association.
Definitely.
My favorite professor.
They're out there. Sorry?
I think someone spoke or someone wasn't on mute. Sorry, we need to mute everybody. Sorry, Srini, please continue.
Oh, no problem. The old is in quotes because old doesn't mean obsolete. It just means been around for a while, still challenges remain. And I do want to spend some time today talking about work that we're doing. And Danny has done a little bit of that. I will add to it. Obviously, data that you don't use for interesting tasks is useless. But the question is, when you compute on data, when you give data away, perhaps you've encrypted it, what is the privacy guarantee associated with this? Can you quantify it? And sometimes there's qualitative differences. Does it conform to applicable laws of the land? And there's other dimensions as well that are concerning to the user, which is how long is it going to take you to get the results that you want? What is the computational cost of quote unquote private computation? And if you've transformed the data, I'll talk about techniques where data is transformed, for example, differential privacy. What happens to this transformed data with respect to utility or accuracy with respect to the answers that you're getting after you've done your processing of the data? And not surprisingly, given that this is a complex problem, there's many different approaches with the many different trade-offs. And one thing I would absolutely like to do is to give you a sense of all of these approaches and some of these trade-offs. And so you can, perhaps choose between one or more depending on your particular scenario. So the first approach is, I should say upfront, is an approach that's been discredited. But I do want to start with this, which is, let's just remove identifying information from the data. If I have a database that looks like this, why don't I just take out the first column that corresponds to the names, and then I'm going to go share this data with anybody and everybody. And well, privacy is, is assured because we don't have the names, and you can get your utility or accuracy because you kept the data the same. This does not work, to be clear, and there's a lot of attributes associated with this data. And in fact, there's been many studies, and this is really only the first of them, way back 15 years ago, that says you can identify 60% of the US population just by looking at 3 attributes, the zip code where the person lives, the birth date, and the gender or sex of the person.
Excuse me.
And so, yep.
I'm sorry, your slides aren't advancing.
Oh.
Yeah, we're seeing just the title slide.
Oh, I'm sorry about that. Can I, what I can do is, can you see now re-identification using linkage?
Yes, I can see that now.
Okay, great. So unfortunately, this is a Zoom bug that constantly props up. And all I've done here is shown you one other slide. So this was the slide where I showed you a database. And what I'll just do is manually step through these slides. I think these slides are large enough that people can read them fairly easily. Sorry about that. They're very advancing on my screen. So you could anonymize the data, as I mentioned, and this would just simply remove the names, but this doesn't quite work. And the reason this doesn't work is all it takes is knowledge of a small number of attributes to identify or name the person. So this approach is not an approach of choice. But let's talk about other approaches. I'm not going to spend a lot of time on the data encryption approach because Danny has spent time on it. But I do want to say that there's really a variety of techniques that you could use that would take your database and really securely encrypt it into gobbledygook that's shown here on the right, where there's no way that you can connect up the zeros and ones that you see on the right to the names of people. So this is really truly secure. The question, of course, is that you've done a radical transformation of the data. And the question is, when you compute on this data, do you actually get the correct results or not? And the amazing thing about cryptography, or crypto magic, as I'm fond of calling it, is that you get precisely the same answer with these provably secure techniques when you compute over the encrypted data. And in fact, depending on the approaches that you use, if you use fully homomorphic encryption, you get an encrypted result that the processor of the data can't interpret the data, but when that encrypted result is sent back to the client can decrypt the data, decrypt the results, I should say, and get the answer. Secure multi-party computation is more of a collaborative exercise where multiple entities can share data and together compute an answer that they all know, but they don't have to share their private data with each other. There are questions associated with these techniques. There are challenges associated with these techniques. In the case of fully homomorphic encryption, the challenge is one of efficiency. It takes much, much longer to compute on encrypted data than it does on plain text. And we're talking about orders of magnitude. So while you can do things in, let's say, microseconds on plain text, it might take you seconds on the encrypted data. Now, of course, if it took you days on the plain text, well, that becomes a problem if you try to use FHE approaches. Secure multi-party computation is a little bit different. I mean, it also has some efficiency issues, but I think the question there is, there are questions of collusion and things like that. So no one size fits all, but there's certainly a place for encrypted computation using either of these approaches. And there's significant work going on at CSAIL on both these techniques. And another approach that I've spent some time on is to build secure hardware and use secure hardware, in particular enclaves inside secure hardware, which are essentially processes inside of a computer, and only inside this process is data decrypted. So data is never exposed except to the hardware. And you can get a certificate of attested execution, as we call it, that says that a particular program was run inside of an enclave, and then an encrypted result is produced. So this is sort of the hardware analog of fully homomorphic encryption. It's much more efficient because you are directly using the hardware on plain text, but there are challenges associated with this. Intel SGX, which is a commercial offering that offers enclaves, suffers from side channel attacks, and there's a whole host of attacks that I'm sure many of you heard of, Spectre, Meltdown, Foreshadow, that were essentially broken Intel SGX. And so that implies that you have to now do better with respect to building the hardware and the attestation mechanisms. I've spent 15 years of my life worrying about secure enclaves and continue to work on risk-based secure enclaves. Another approach is to mediate access. So here you'd say that let's have a trusted curator who is going to be in between the data analysts and the database, and the trusted curator can see the data, which is potentially a problem. Say that up front, but the data analysts don't get to see the data, and they get their queries answered, and there's some leakage that is associated with the answer to the queries, but the curator can manage that, etc. The biggest problem, of course, here is that it's very hard to imagine situations where, or it's easy, I should say, to imagine situations where trusted curators are not viable. So then finally, there's differential privacy, which is an approach that's being used where the curator is no longer trusted, because what you're going to do here is you're going to try to hide the effect of each individual. You're going to try to anonymize each individual by perturbing the data. The curator, you could do that perturbation. You could assume that the curator is doing the perturbation, which is a certain level of trust, but you can do even better than that. Local differential privacy says you perturb your inputs before you send it over to the database. And the requirement here of perturbation is that the effect of each individual should be hidden. So briefly, what this means is, let's say that we zoom in on the second line here that corresponds to a male with the blood type of A, etc. And obviously, there's some sensitive information here associated with HIV positive or not. And you want to protect this individual and the privacy of this individual. And what you want to do is perturb the database, either locally or in combination of between multiple distrusting entities, to say that whatever the query is that a data analyst asks for, or whatever the details of the query are, whether the second line could be empty, could be deleted from the database, you could change it from male to female, the HIV positive or not. You should be in a situation where you've added noise such that the query to the database that was uncorrupted, if you will, or not perturbed, gives you the same answer for this aggregate query that the perturbed database would give you. And there's a theoretical rigorous treatment of this that is in the field of differential privacy that essentially says that you can quantify the amount of noise that you need to add to a database in order to protect each individual from being discovered with respect to their specific attributes. And there's a lot of work going on outside of CSAIL and inside of CSAIL. And the bottom line is that for aggregate queries, you need to add very little noise for large databases. If an n tends to be large or tends to infinity, a small amount of noise can protect an individual. So this is a pretty important realization, and differential privacy is an old technique. And it's been deployed, mostly focused on count and average statistics. Apple and Google's repo, and the United States Census is committed a few years ago to use differential privacy for certain aspects of aggregate statistics computation. But there's some challenges that still remain. What happens when you have a small database? You have to manage and model this privacy loss over time, because this guarantee of differential privacy is for a single query. So if you constantly query the database, well, you're learning more and more about the database, not surprisingly, and you have to quantify that privacy loss. And sometimes you have to not report on answers because you've exhausted your privacy budget. So that's obviously not a great situation, because now you're not allowing data analysts to analyze the data. And there are a couple of other things. Matching guarantees with privacy law and regulation is something that we're quite excited about here, especially in the context of this initiative. And there's significant work at CSAIL addressing all of these challenges. But these challenges are by no means solved at this point. So I want to end with talking about, well, I guess the work that I'm most excited about, which is the most recent work that we're doing, which is kind of the usual thing here with everybody, all researchers at CSAIL and perhaps worldwide. And this approach is trying to address the computational efficiency challenges associated with encrypted computation, the usability challenges associated with differential privacy, and it's got its own set of challenges, but they're a little bit different, and I'll spend just a few minutes describing this to you. So the idea here at the top level is that we want to transform the data and just sort of give it away. And so it's a little bit like the encrypted computation approach, where you can expose this transformed data, except that it's not encryption. It's a different kind of private transform where you are, perhaps adding noise, maybe even multiplying the data with a random matrix, etc. So I won't say very much about the transform itself, but think of it as X gets transformed to T of X, and then this T of X is sent, it's exposed. So you have to now worry about what leaks about X, given that you've exposed T of X, and you need to do some analysis with respect to privacy guarantees, and we are certainly doing that. But the idea is that the untrusted entity that now has T of X in its possession learns some model. And so this could be a machine learning task, and you have an encrypted database of images, and you learn a model, I should say a transformed database of images, T of X, and you learn a model based on it. And then you send the model back to the owner of the data, and now the owner to make a query on this, and you could certainly do this and leave it at you, the untrusted entity, but basically you have to take every sample that you have corresponding to the query, and you have to transform that as well, because this model was created on the transformed data. And as I've said, how much does T of X leak about X? And then the other question is, if you modify the data substantially, T of X has to have some properties that are relating to X, obviously, because otherwise the model M is not going to be useful to either the data owner or anybody else. And so it's a powerful idea. And one of the ideas that actually, a simpler idea that works in practice is, a related idea is one of data augmentation. And mix-up, which was only proposed a couple of years ago by a couple of researchers at Princeton, I think, is a data augmentation technique that says it was actually proposed to increase the size of data that the data set that one has, but there's also a privacy observation that you can make here that we exploit. And that is that if you have two samples, X and Y, you could imagine creating a new sample basically based on a random combination of the two samples. So just pick a number R, and then multiply the first sample by R, and multiply the second sample by 1 minus R, and create a new sample. And it turns out that you can increase the size of your data set and improve your utility, nothing to do with privacy, using mix-up, and this was earlier work. What is interesting here, an observation that we're exploiting, is that even if X is public, if you keep R secret, then there's some privacy associated with exposing this mixed sample because R is secret, and obviously, and let's say Y is the sample you want to protect. And so you can actually use this idea in conjunction with uniform transformations. And this is a framework we're building. And I'm quite pleased about this name. It took me a while to come up with this. But it's basic. Just to walk through this really quickly, you do some data preprocessing or augmentation. You do a transformation on the data. At this point, you need to have a privacy proof that essentially says that the data that's sent over to the server is only going to leak X amount of bits, or does not leak anything, etc. You train on the model. So this is very similar to encrypted computation, except that you've not actually encrypted the data in the true sense. And then you send back the trained model, and this model can now be used by the user. We're not quite ready to publish papers on this topic, but we're like a few weeks away. And I'm excited enough about it that I want to giving you a preview. But the big questions are, and some of which are answered, are how do you choose to transform so you can choose a privacy property, and what the resulting utility on learning on the T of X is. The nice thing about this is that you're not paying the cost of transformation over and over. You essentially do get data at the end of it, and it's transformed, and it's a little bit like differential privacy, where it's very efficient to answer queries and learn on the transformed data. The big question is utility, and you can choose the transform in order to get utility for a particular task. So that certainly the transform that you choose depends on the queries that you want to answer. And that's something that we still need to work on. So let me close with a summary of what I just talked about, which is really, this is a huge problem. It's not surprising that we need a slew of techniques. There's really a wide variety of techniques. Hopefully you've gotten a sense of that from the short talk. There's a lot of work at CSAIL and elsewhere that are addressing these challenges, and we're really excited about working with you to address specific research challenges. So I'm going to go ahead and stop my screen share, and I think we have time for a couple of questions before the break, I think. So,
yep, absolutely. Yeah. So Matt, do you have questions specifically for Srini?
Yep, I was wondering, we have a question. What types of cybersecurity challenges are you currently exploring or planning to explore?
The focus here of this talk was data privacy, and so I won't say much more about it, but in the context of cybersecurity, there's everything from outsourced computation to building web servers that are secure against remote attacks, and there's work on building side channel resistant hardware, and so on and so forth. I mean, I could go on. I mean, there's probably I have actually a talk that is a much longer talk that would be nice to share with the attendees at some point, that gives people a sense of the breadth of work that goes on in ECS and CSAIL and MIT, I would say, broadly speaking, and on addressing cybersecurity challenges. But it's not something that I could answer in 30 seconds, but there's a whole lot of work ranging from programming languages, computer architecture, to machine learning, and there's different challenges associated with each of these fields. And I would say there's people here working on all of those topics. So.
Fantastic, great. Well, that brings us to the top of the hour, and we know everyone must be getting hungry, but we were hoping to give you just about 10-15 minutes. Go grab something to eat and then come back and join us, because we are going to have a very robust Q&A. We've received many questions that are really relevant to a lot of different challenges with industry, different research challenges. And this topic, again, is just so timely and relevant in so many areas. So we've got an amazing amount of great questions, and we're going to give the opportunity to the researchers to be able to address those questions directly. And still, if you do have questions you want to submit in the chat, we can certainly do that as well. So we are going to start again at 12:15. So please do go grab a quick bite and come back and join us. And we'll be here waiting. So thanks to everybody in 15 minutes. Okay. Well, I hope everyone was able to grab a quick bite to eat. And thank you for sticking with us. So now we do have quite a few questions. And Matt is going to offer the questions to both Danny and Srini. So with that, Matt, why don't we start the Q&A session?
Thank you, Lori. One question we have regarding SCRAM and cybersecurity benchmarking and ROI analytics. What resources are available for companies to perform quantification of these security matrices?
That's a great question, and the answer is we are right now inviting companies to participate in these research studies with us. So the results that I showed were the result of an analysis we did with 6 large enterprises. We are going to do a next round of computation in February, and we'd love to have participation from anyone who's interested. Essentially, what's required is for companies that already are kind of tracking their control status, their cyber defense control status, and tracking attacks. What's required is that they put that information in a particular form, run it through a local encryption process, and then get it to us. And then anyone who participates in that study would get results back, obviously, about their own posture, but more importantly, would be able to compare themselves, their own defense posture, their own risk level against others in the cohort. So it's a kind of a share and share alike research process. If you participate, you get by contributing your data, you get the results of the analysis, and we're right now putting that group together. So feel free to be in touch with me or Taylor Reynolds, who's probably on the maybe on this this Zoom, but Lori or Matt can hook you up with us, and we'll be happy to talk with you about it. And let me just say, the long run goal is to have a well-validated set of cyber risk metrics that eventually we'd be able to compute, not unlike the way financial indices are calculated or others. The research that we're doing right now is about figuring out exactly what those metrics are and how to compute them over a statistically significant group of enterprises.
Thank you, Danny. We got this question in right after Srini's presentation regarding the operationalization of the methods defined by Srini in the context of implementation. Are these part of popular frameworks and libraries, and can they be operational with performance consideration, or is there some time before we see them in practice?
Great question. So obviously a function of the specific technique. Let me start with what I think is unfortunately the furthest away, and that has to do with building new hardware. It's unfortunate that it takes such a long time. The hardware cycle is 5 years. So ideas that we work on, we've built secure processors at MIT, and we can deploy them, interestingly, on Amazon F1 instances, which are things that other people could use. But those are essentially, think of them as emulations, and they're not widely deployed. You have to build a chip, and a company has to build chips and sell them. So I would say that work in secure hardware would be 5 years away at least, right? Maybe 5 to 10. The good news is that on all of the other techniques that were described both by Danny and myself, their software, there's obviously two things associated with that, which is the proof of security, which ends up being something that needs to be checked as well. But it's all pencil and paper, if you will. And then there's software implementations. And so those are much closer, I think, to being deployed. And new techniques can roll over into the real world, fairly quickly in the time frame of 1 to 2 years. So differential privacy, for example, there's frameworks for differential privacy. There's frameworks for federated learning. There's frameworks for fully homomorphic encryption. There's libraries that you could use to download and evaluate. And it's obviously, I'm not going to give you the web pointers here, but feel free to get in touch with me about specific questions that you have on specific frameworks, and the answer is generally yes. Right. So.
Let me just add one quick point to Srini's response. What we found in putting together the Scram platform is that while there are some very good libraries for some of the basic secure computing techniques, there are lots and lots of questions about how to actually implement them in a reliable way. There are lots and lots of questions about the overall security guarantees and privacy guarantees that they provide. And so, I think we're in a stage with a lot of this technology of, I'd say it's applied research. The basic techniques, as Srini suggested, are well understood and well defined, but understanding how to use those in in a practical way, ways that meet actual policy requirements or actual enterprise requirements. Even understanding how to integrate them into larger systems, I think, is a major challenge. And we view this initiative as making sure that the technologies that are important here get over that hump from conceptually available to well enough understood and implemented that they can actually get into the commercial product stream and get, well, obviously, as Srini said, that's a very different story if you're talking about new hardware, but even just getting these techniques into an enterprise software platform is it's not just a matter of reading the papers and going and implementing. There's and really one of the reasons we're excited about working with people on this call is we think we've got to answer a lot of those practical questions. And again, that was our experience with Scram, is that we believed we had libraries that could do all the basic things we needed, and a year later we actually got them to all work right. So so that's an important part of this effort.
Thank you both. For Srini, in industry, there are significant concerns about performance and privacy preserving machine learning techniques. What are some of the real-time-ish friendly techniques which enterprises can use today?
Yeah, machine learning itself is so time-consuming. I briefly alluded to this during the talk. I mean, if you have a computation that runs in let's say a matter of seconds, and you're willing to wait minutes or hours, then encrypted computation is viable. But if the computation itself takes days, I mean, you don't have the years, the centuries, if you will, to wait for the computation to end. And unfortunately, some of these techniques, in order to ensure privacy, the overheads are orders of magnitude. It doesn't mean they aren't useful in certain settings. I think machine learning is kind of the highest bar at this point here, because people are struggling to use deep neural nets to even complete, to finish their learning tasks on exposed data, on non-private data, right? So that's partly why I got excited about the area, because it was fairly clear that encrypted computation a la conventional cryptography wasn't immediately applicable to the privacy-preserving machine learning world for the reasons I just stated. And so there's I think a new set of techniques that are coming out that are all these let's transform the data, and let's prove things about the security of the transformed data, and let's hope that we've chosen the transform correctly, such that the utility of in terms of the quality of the answers you get for the queries is reasonable, or it meets your bar. Early days yet. Early days yet. But I think a combination of techniques, I think, like I said, encrypted computation has its place, differential privacy has its place. And I can see that there's a lot of momentum, behind this new set of approaches. And there's papers now being published, not a whole lot. I mean, it's not hundreds of papers, but there's a few here in every year. And this might be something where we're going to see a wave of new techniques fairly soon. Right? So.
Thank you. This came in for Danny. In terms of the legal aspects as it relates to the discussion today, do you see a need for a data privacy law to be improved? In which aspect of it?
Yeah, it's a great question. I will say I took a couple of years off from MIT, spent a few years in the Obama administration, and spent a lot of time. We proposed at the time that there should be a comprehensive data protection law in the US. That was 2012. We were ahead of the Europeans. The Europeans are now ahead of us. And as Lori mentioned, California has enacted a law. There are a few other states that are considering laws. I think that, certainly having a comprehensive framework, a comprehensive law is important because it's important to know that regardless of whether you're looking from a European perspective or US perspective or anywhere else in the world, those are really just starting points. They're broad frameworks, and they have to be interpreted, as people know who spend time on this. They have to be interpreted and applied in particular context, in particular sectors, to particular kinds of data. So right now, the de facto privacy law for most of the world, minus China, is the GDPR. And the question is how to make it work well. I think that, and if the US were to adopt a comprehensive privacy law at the federal level, it would have to look a lot like the GDPR. It would be different in some ways, but the broad substantive policy would be basically the same, because that's the world, if nothing else, because for any of you who are in large global consumer-facing companies or even global business-to-business organizations, you'll know that mostly you've made a decision that says that GDPR is the de facto sort of high bar rule that you have to follow, and it's easier to follow that than to do that for all your European operations and something totally different for somewhere else. So I guess my answer is we kind of know what privacy law looks like now at the broad level, and the question is how to be able to interpret it and implement it. And that's where I think the very concrete questions, whether it's questions about, well, how do some of the technologies that Srini's talking about actually, what does it take to use those to satisfy privacy requirements? What do you have to do in the various frameworks that Srini mentioned, whether it's Dauntless or something else, to show that your implementation, for example, means that the data isn't regulated as personal data because it's been successfully protected as a technical matter. Those are the kinds of questions that I think that we really need to be able to make contributions on, so that as that technology is developing, we can make sure that people who want to use it, who want to do the right thing, who want to be respectful of the law, can pick up these tools and use them and have confidence that they've satisfied their obligations. If you go ask a regulator that question today, would Dauntless work? Would differential privacy set at an epsilon value of 0.8, does that satisfy my obligations? You got a shrug of the shoulders for the most part. And we've got that's the hurdle that we got to get past, regardless of what happens in the legislative environment, because I think the framework that we are living in is basically set for a while.
Thank you, Danny. And kind of following up on that, do you see big data companies adapting it, GDPR by applying it universally, or do you think they'll maintain multiple privacy standards in order to use their old business models as long as possible?
Yeah. So obviously, I kind of answered that broad brush. I think lots of enterprises, if enterprises can just comply with the GDPR, they mostly do, because it's just easier. You have some areas of GDPR requirements. For example, the way that ad networks function in the EU is different the way that they function in the US and in other non-GDPR jurisdictions. But I think even that is likely to change. I think a lot of the ad tech companies are looking at how to move, the big ad networks are looking at how to move towards more privacy preserving kinds of profiling using some of the techniques that Srini's talking about. So remember, advertisers don't actually care about having accurate targeting and profiling, but don't actually care about whether they have, in most cases, whether they actually themselves have complete possession of and control of the underlying personal data. They just want the profile right. And the way they do that now is to collect everything they can possibly find. But to the extent that there are learning techniques that are operated more locally, that are operated in privacy-preserving manners, I think that's going to become more popular in some part, again, because of the pressure that GDPR exerts.
Thank you. Another question, how is technology and automation helping in continuous monitoring of compliance and privacy concerns?
Not enough is the simple answer. And, you know, those of you who are at all focused on the architectures of your enterprises, either from a database perspective or a security perspective, know that you probably have massive amounts of log data, whether it's for intrusion detection or exfiltration detection or other purposes, or for monitoring compliance with database rules. But for the most part, I think enterprises that are honest with themselves will say that they really don't know what to do with most of the log data they have. And that's because it's very hard to connect. Take the example of just relational database logs. It's very hard to do a mapping from a privacy commitment that's made in a company's privacy policy that they write out in legal terms. It's very hard to map that to events that are recorded in a database log. And so the work that we've done that I've mentioned that starts to try to express purpose limitations in database structures starts to close that gap. You know, there are interesting startups that are working on these questions, but I think we're still really far away from. We certainly don't have in the commercial space this ability to map from legal requirements to technical behaviors, and until you have that, you can't really do automated monitoring with any seriousness. And it's a major goal of this initiative to close that gap.
Thank you. How are increasing demands of financial technology and digital transformation impacting the cybersecurity and safety of data?
Well, I mean, I think there's a lot of transfer of money going on, much more so thanks to cryptocurrencies, among other things, in the last year or so than 10 years ago. So I think there's a lot of the technologies that we've talked about here, including secure hardware, I should say, are potentially useful in this context. Like crypto wallets, for example, you need to be secure hardware, and obviously a very different kind of secure hardware from Intel SGX, because this is something that you carry in your pocket. But you want physical security associated with it. If you lose your wallet, you want to have a two-factor system to not lose your private key, and you also want backups and so on and so forth. So I think that scale and the value of financial transactions is increased. I mean, that's one aspect of it, and maybe one aspect of this question. And then the other side, there's financial data that can't be shared, or from a standpoint of companies, not being able to share it with other companies, even if they wanted to. I think there's the aggregation of financial data across companies can potentially produce better results with respect to whatever answers that you want about the financial climate. Right? So
one of the really interesting regulatory developments regarding financial data is the open banking APIs that have been encouraged in the first instance in the UK. and have are spreading around the world in various ways. So these are one of the privacy rights that individuals have as a result of GDPR and other privacy laws is the right to access data. And increasingly regulators are saying, well, that means you have a right to access the data, in digital form, in a, convenient, machine readable, across some API that you can actually work with, so that you can actually make practical use of the data. The British banking regulators made the decision that it would be good for innovation in the fintech sector to open up everyone's banking data, obviously with appropriate security, but to be able to say that, so if you have a bank account and you want to ingest that information into say maybe a accounting software, or you want to be able to make that data available for some kind of modeling to prove that you're available for that you're qualified for a loan or something like that. The trend is towards opening up access to these very sensitive and very valuable repositories of personal financial data, and obviously, how you do that. The sort of OAuth style APIs are the basis of the sort of point-to-point access. But I think we're heading into an environment where there's the potential for a lot of innovation and a lot of customer value if people can actually successfully share their data around to different services. But that obviously requires a much higher degree of security than we're currently capable of. So I think there's this new set of demands just based on the increasing fluidity of financial data, and the same thing obviously happens at a kind of a business to business level. If you look at some of the big the big data breaches, they actually occurred on kind of ancillary parts of financial services company systems that were used specifically to support these data sharing APIs. So companies want to do. I happen to hate the phrase "data is the new oil," but data certainly has value, and companies want to figure out how to share that value and collectively leverage that value. That means you need a reliable environment in which to do it. So I think there's enormous, very important challenges there, all of which require the ability to monitor in real time the security status and fraud status of these kinds of environments.
Thank you, Danny. One question we're getting quite a bit is just in terms of social media and privacy regarding, Facebook, WhatsApp, Instagram. For example, one question received is natural language processing advances. Social apps can use it to overhear and analyze conversations. Is there a data privacy issue here, and how can we deal with it?
Wow, I mean, that's a difficult and broad question. Let me try and take a stab at it. So I think end-to-end encryption is a pretty solid technique, and by that I mean it's academically solid, and I think it's been deployed in a fairly robust fashion, and things in WhatsApp and Signal and things like that. Now the question is, assuming that you have authenticated the person you're talking to, and this is obviously, let's say if it's friends talking, there's no issue here. But if there's any sort of cryptographic key exchange associated with that, then there are attacks that are possible on faking people's public keys, so the man-in-the-middle attacks and so on and so forth. And so this end-to-end encryption assumes that you've done a secure key exchange. I mean, just to put a fine point on it. But so I think if you do a secure key exchange and you have end-to-end encryption, you don't have to worry about NLP attacks, and you don't have to worry about people eavesdropping because they only see encrypted bits. I mean, they cannot interpret those bits in any fashion. I mean, the audio is encrypted, the video is encrypted. But there's obviously, a whole host of other attacks that are possible on the user. So the phishing attack on the user could compromise the user's identity, could compromise the user's keys. You might have attacks on servers, let's say Zoom servers or WhatsApp servers. That's also entirely possible. I mean, as Danny just mentioned, I mean, these financial service companies, when they open things up, they end up, unfortunately, creating new attack surfaces for attackers. And at some level, there's sort of a honeypot thing where attacking enterprises and attacking enterprise servers is much more lucrative to an attacker than attacking an individual. So one should be concerned about it because I think there's more attacks that are directed towards that. So anyway, those are my thoughts on it. I'll turn it over to Danny.
I'll say one additional thing about, I think Srini's right to point to the shift towards more and more of end-to-end encrypted messaging environments. That's, all the Facebook messaging platforms are now unified in one end-to-end system, and then there's Signal and Telegram and others, and Apple iMessage. I think the interesting question is to what extent. So those, of course, are both allow for bilateral communication, but also multi-point end-to-end computation. So communication. So I think the question, my sense that a lot of the social media platforms are trying to figure out is social activity going to kind of migrate more towards these smaller group, closed, end-to-end encrypted environments, as opposed to the more open kinds of interaction that we're used to on a sort of typical Facebook or Twitter, where everyone or large groups of people can see most of what's going on. If that, I think the social media companies appear to believe that people want those more closed, more secure kinds of smaller group or one-on-one interactions. WhatsApp kind of made its name being able to do this, and others, of course, do it as well. I think what's one of the challenges that raises is, first of all, that the social media platforms will have a much harder time monetizing those interactions because they won't be able to see as much of them. And law enforcement actually gets worried about those kinds of interactions. If you read the reports about the investigations immediately following the insurrection in DC, when Parler got shut down, which was a very open platform, lots of the communication apparently moved to closed WhatsApp and other Signal and Telegram and other platforms. That makes it harder for law enforcement as well. So I think there's kind of an interesting, social question about whether we're all going to, go off and hide in these sort of ad hoc, highly protected little environments. There'll probably be a mix of both. The one thing I'll say about the broader, I think the broader question was about what ought the privacy rules to be. There's a real intersection now between privacy questions on these large social media platforms and antitrust law and competition questions. So you may have one view of the privacy policy of a social media platform if you believe that users can easily migrate to another platform if they don't like the privacy environment on where they started. That's obviously increasingly difficult. It's hard to move, period, off a social media platform because you lose your friends, you lose the network of relationships that you developed. But I think both in there are now investigations at the U.S. federal level by a number of state attorneys general, by European regulators, into essentially whether Facebook is too big, whether Google is too big. And that, it seems quite interestingly, one of the proposed remedies for the worries about anti-competitive behavior by the platforms is to actually open up more access to user data so that other platforms can develop. So there's kind of mixed signals about privacy now. As the platforms get bigger, they're actually happier and happier to protect your privacy as long as you stay on their platform. I think it's a complicated set of questions. Part of it is kind of traditional online advertising privacy questions, but part of it is going to be about the extent to which part of the solution to the kind of antitrust complaints about the big platforms is going to be solved through new privacy rules. So we'll certainly be watching all that and part of that discussion.
Thank you both for answering that question. Do you have an analysis or research on the cost benefits to implement preventative technology or system solutions for privacy compared to detective or manual procedures?
So the way I think about it is that, I would categorize the techniques that, most of the techniques that I described in my talk, and obviously Danny described encrypted computation as well, as preventative techniques, because you're essentially assuming the worst. You're assuming that the person that you actually want to use their computing resources off, or who's doing the computing for you, is an adversary, and you want to prevent them from learning aspects of your private data or anything about your private data. So there's costs associated with it, and I won't repeat myself with respect to the various trade-offs, since we've beaten on that a little bit here. In terms of active, well, I worry a little bit about. There's the sort of the intrusion detection. You have your server, and you're protecting yourself from attacks. But once the data is leaked, the data is leaked. It's done. There's no going back there. So in some sense, it's like there's no success there. Well, the success is, I guess, status quo, and then there's only failure. But I guess in the context of let's say web services, I think and denial of service attacks on web services. And perhaps that's probably the best example. Certainly, I think you could have an intrusion detection system where you see the load on your server increasing, or you see sudden strange requests coming into your database, and perhaps trying to extract information about particular users. And I could totally see, and there are, I think, examples of monitoring programs that look for outlier behavior, right? And you pay a constant cost, an online cost associated with trying to detect this intrusive behavior. And there's sort of the false positive, false negative kind of issue associated with this. And sometimes you're shutting down legitimate requests, and sometimes you're letting illegitimate requests leak through. And so it's a completely different ballgame. And I think it's a good point. It's a good question. I'd say the online cost is certainly greater. It does feel like for some of the techniques that are preventative, that it's an upfront cost, right? It's not the greatest answer, I'd say. I think it's a little more nuanced than that, but that's all I got here.
Yeah. So our focus on trying to understand costs of these different mechanisms really is through the SCRAM project, and we're working to be able to understand the return on investment of different security controls. There's a lot of work, as many of you know, in defining different kinds of controls, a bunch of different frameworks. We've used those frameworks to describe how an enterprise protects itself, and then are able to look at the costs of failure of any one of those controls. And of course, you can also look at the costs of implementing those controls. So one of the reasons we have, I neglected to mention at the beginning, one of the lead investigators on the SCRAM project is Professor Andrew Lowe, who's an economist at Sloan, and has spent most of his career working on quantifying financial market risk. We asked Andrew to work with us because he understands about how to price risk, and that's what. So we're concentrated on doing that with respect to various kinds of cybersecurity controls, and we'll have more and more data there. I think it is interesting. We may be able to apply some of those techniques to privacy compliance as well as we get better and better at it.
Thank you both. As we kind of wind down, I do have another question where you both see the key opportunity for innovation that lies in data platform management.
Go ahead, Danny.
So I think what we all recognize is that there is still enormous unrealized value in the data that enterprises hold. And we don't realize that value. And by the way, that extends to what you might think of as data close to enterprises, all the sensor data that we're collecting, whether it's through the movement of smartphones or health telemetry or any traffic movement. That's data that we actually keep separate from a lot of other data because we're nervous about the security and privacy risks of too much data integration. So I think the overriding opportunity is to increase trust in the way personal data is handled so that we can get more core value out of that. I'll give one really quick example. When the pandemic started, Srini and my colleague, Ron Rivest, got a bunch of us together and said, we need to figure out how to do better contact tracing, digital contact tracing using smartphones, and worked out a privacy preserving protocol for exposure notification for detecting close contacts with people who might be infected with COVID. That was implemented very quickly by Apple and Google. And what that reflected was a way to kind of bring together sources of technical trust with institutional trust to say to people, look, there's something important you can do. You can reduce your risk of being exposed to COVID. You can help your community reduce the spread overall. But it asked people to trust that, number one, the underlying cryptographic protocols were actually secure, and number two, that the companies implementing them, Apple and Google, maybe some varying levels of trust. No offense intended to anyone in those companies, and it worked. And I think that's a model for making sure that as we move ahead with what are going to be, I think, data integration, data analytic efforts that may make people nervous, we have to figure out how to build up trust on the other side. So I think all these technologies, all the approaches that Srini talked about, some of the work that I talked about, it all adds up to building tools that merit technical trust and that are well enough integrated into our policy and legal and social understandings that people can look at them and say, yeah, we should be willing to trust that. So that's where the opportunity is.
Right. So yeah, so I think I would just summarize all of that in one sentence. A data platform for private collaborative learning,
Yep.
right? It's because we didn't talk about collaboration very much. Danny just talked about it.
Yeah.
But I think that's something that we probably should spend more time on, thinking about, which is the fact is there's a lot of value. I mean, Danny did talk about the value in the data, and the value comes from aggregating data. The value comes from collaborating on data. So I think the three big things are, well, we want privacy, and there's policies associated with the privacy properties that we need to have. There's value in the data and value in sharing the data. But how do you maintain the privacy property when you share the data and you collaborate on it? And then at the end of it, it's just, I mean, can you do this, in a reasonable amount of time? I mean, there's cryptography can help, but if you're talking about a data platform and you're talking about terabytes of data, efficiency is going to very quickly be an issue. Not as much in the COVID exposure example, which was, very simple computation. I mean, very, very critical data. The fact that you tested positive or not is very critical, but it's like percentages and adding up a bunch of numbers. So there, I think cryptography is like the thing to do. But machine learning, there was a question on that. I think it's a different ballgame because the amount of computation is orders of magnitude more.
Great, fantastic. Thank you both. So now I'm just going to kind of share my screen and say, where do we go from here? And we really have had some great conversations, and I'd love to keep everyone engaged and kind of just go through where it is. So here we go. All right. So we already did that. So the Future Trust and Privacy, this is a new initiative that we are going to be launching. So the structure is going to have both the technical research and the policy in it. Technical research areas highlighted are database systems, applied cryptography, AI, machine learning, data portability, new information structures, a lot of which was covered today, highlights, and HCI. Then policy dialogue and public engagement as it relates to technical areas. There's going to be a lot of opportunities to have researchers, policymakers, industry initiative members, and partners be able to participate in the conversations. The engagement is, in order to be truly impactful, we really need to work with industry and government and other organizations here. And we're really glad that you're able to join the talk today and hope to continue the conversation. The opportunities, anywhere from attending sessions to joining the initiative and committing to serve on the executive committee. Specifically, the executive committee is going to do things like play the role of surfacing important data governance challenges, share information on best practices for data governance, insight on technical needs, and input in conferences and the workshop agendas, as well as inform the initiative on areas of professional development. Because ultimately, the work that we do here, we want to be able to share, of course, through workshops, but also programs that can really be shared across the enterprise and really help companies address some of these issues. So in terms of follow-up, we are going to send information on the plan. For everyone who attended, I welcome your feedback. We're going to be launching the initiative in the next few weeks. So we do have some founding members who will be speaking at the launch. And of course, we'd love to invite you to the launch. If you'd like to hear more about this, you're welcome to attend. If you're interested in getting involved, please do let me know, because this area is really of great importance to companies large and small, no matter what industry. Getting ahead of the curve, understanding how these technologies address the challenges, and having the discussions with the policymakers are all really critical to the future of data. So with that, I'd like to just thank you all for attending. I think we're right about at the top of the hour. Perfect timing. Wonderful. This is my contact information if anyone wants to reach out to me directly. Other than that, I will be sending a follow-up to everyone. And thank you again, and enjoy the rest of the afternoon. Thank you.